In this video, we're now going to go ahead and we're going to be solving for x. Notice that x is my exponent in this particular power that we see here. Remember, as we've seen in the other video that we had, this 2 represents my base, and this x represents my exponent, and the 7 represents my answer. Now we're going to use our idea of a logarithm in order to solve this, because this is a bit of a difficult one to solve. Notice it says 2 to the power of x equals 7. Now I can take my calculator, and you could do guess and check methods. You could say, well, you know what, Mr. H, I could just get my calculator and I could try to just throw random numbers in there to see if I can get a 7. Well, if we put 1 in there, it just gives us 2. 2 to the power of 2 gives us 4. 2 to the power of 3 gives us 8. And notice 8 is more than 7. So in this situation, you know that we're going to have some fractional value in here. But we don't know what the fractional value, or it may not even be a fraction. It may not be able to be written as a fraction. It could be a decimal value. And so how do we find out what the exponent is? Since our basic integers, 1, 2, and 3, for instance, don't work. We have one that's too small and another that's way too big. So in this case, this is where logarithms can really help out. So what we're going to do is we're going to turn this into a logarithm. And that's going to make it really easy to solve so that we can get an approximate value of what this exponent should be. In other words, what the value of x for. Because our goal is to solve for that x, to figure out what number can we put as the exponent in order to achieve 7 as our answer. So there's a couple different methods we can use to solve this, but what I'm going to do at this point is I'm going to turn this left side of the equation into a log and the right side into a log. In other words, I'm going to write this out as log 2x is equal to log 7. So all I did, notice I have log 7 over here on the right. I have to deal with this exponent here. So I'm going to take this exponent here, because there's a rule and it says this exponent, we can actually rewrite this as x times log of 2 is equal to log 7. And once we get here, notice this is just x being multiplied to the log. Now what we can do from this point is, again, I'm going to use inverse operations, but what I'm going to do is divide out just the log 2. Now if I divide it on the left side, I got to divide it on the right. So I'm going to go ahead and do the same thing, divide it by log 2. So now on the left side, this log of 2 cancels out, and all I'm left with is just x is equal to log of 7 divided by log of 2. Now, why this is the answer here, right? If you want an approximate value, we can actually simply just put that in the calculator from this point and get an approximate value. So I'm going to go ahead and write that right here. I'm going to put x is equal to, and actually I'm not even going to put equal, I'm going to put an approximate symbol. You see these little kind of squiggly lines representing an equal sign. It means we're going to approximate this value because it's going to give us an answer that's a decimal. So I'm going to take my calculator real quick, hit enter. And then what I want to do is I want to go ahead, I'm going to hit the log button on it, log, and I'm going to put in this first one, log 7. And then I'm going to divide it by log 2. If I hit enter, notice it gives me 2.807354922. Now these little symbols here means I'm approximating it. So I'm going to approximate it to just the tens place. So I'm going to round this as just 2.8. And that would be my answer. Now there's a couple different ways that we could have done this. Also, I know a lot of times we use the alpha y equals so that we can get our fraction bar. But if you like using a fraction bar, you could have still put it in that way just to show you an example, right? And we could have hit log 2. Still going to get the exact same answer. Now there is one other way we could have done it. Now if your teacher's not asking for you to show the work like this and they just want you to give an approximate value, there's even a faster way than going through this process, right? Which is just one method of many to be able to solve it. The other way that we could have done this, I'm going to draw a line to kind of separate it, and what I think is actually easier, if we're just trying to approximate it, is to just convert this to a log. In other words, in the other video, when I introduced it to you, I said that we can simply convert this into a log because in a log, we have a base, an exponent, and an answer. In other words, I could rewrite this as log 2, which is my base, and notice the base is always the subscript. We're writing it as a log. And then I can go ahead and put the answer, 7. So a log with a base of 2 of 7. All right, and then we're going to go ahead and put equals x. Now you may be looking at this going, well, Mr. H, this doesn't seem to help me very much because I still have an x here. I don't know what it is. Well, all I'm going to do, if log with a base of 2, a log 7 with a base of 2, if we have it and it's equal to x, we can simply just put log base of 2, 7 into the calculator, and it'll actually calculate it for us. And then we can see what x is. So I'm just going to write here, x is equal to, and I'm going to show you what I mean by that. So I'm going to get my calculator, move it over here, and I'm going to go ahead and hit my log button. Now in this case, I'm going to do something a little bit different. I'm going to hit math and actually go to log base. All right, so if I hit enter, now this one, it doesn't have the base. Remember that anytime we don't put the base, it's always implied that it's 10. So these ones up here, log of 7 divided by log of 2, those are all a base of 10. Here we have a base and it's 2, and that was given to us, right, when they give us the exponent. So I'm going to put a 2 in there. I'm going to skip over. I'm going to put a 7 in the parentheses, skip over, and now I have, just like I have on the left side of the equal sign, log 2, 7, right? Log with a base of 2, 7. And I'm going to hit enter, and notice it gives me the exact same answer. So I'm going to go ahead and write that down. It's 2.8 if we round it. So approximately 2.8. Now, me personally, why your teacher may ask you to do it this way on the right, you know, they could ask you to actually show your work and use inverse operations. I feel like this way on the left over here, if you're just trying to get the approximate value of that log, this is the fastest way to do it. So let's go ahead and let's look at this next one. Now, our first answer, we ended up having a value that was an approximate value. We do have answers sometimes that are integers and even answers that are fractions. So we're going to take a look at these other types of answers. And so, for instance, on this one right here, probably some of you may be able to look at this and even figure out what number you're supposed to put in for x. But to keep it very simple, I'm just going to go ahead and convert this equation right here into a log. So this is just going to be log with a base of 3. That's this 3 that's right here. And notice it says it's equal to 27, so I'm going to write 27. And then that's going to be equal to my exponent, which is x. And so once I go ahead and I put this in the calculator, I'll know exactly what x is equal to, because x is equal to this log right here. So I'm going to take my calculator, and I'll go ahead and hit math, click up, and go to log base, hit enter, and I'll put my base value, which is 3. And then it's a log of 27, so I'll put a 27 in there, and hit enter, and notice it gives me a positive 3. So in this case, x is equal to positive 3. And let's take a look at example number 3. So example number 3, once again, we have 2 to the power of x, right? Or with an exponent of x is equal to 1 over 8. Now this one is more complex. I feel like these are kind of hard to do without converting it to a logarithm. So I'm going to go ahead and convert it real quick. Log. And notice I have a base of 2. So my base of 2. My answer was 1 over 8, so I'll put that next. And that's simply equal to x. In this case, x, and notice I'm just keeping x on the same side this time, is equal to, and I'm just going to put this in the calculator and see what it gives me and write that answer there. So I'm going to go ahead and grab my calculator, and I'll hit math. And once I go here, I'm going to put my base of 2 in, and then my log is going to be 1 over 8. So I'll go ahead alpha y equals 1 over 8. And now, notice it looks just like what I got written on the paper. When I put it in its logarithmic form, I'm going to hit enter, and notice it gives me -3. So I'm going to write that down. So this is going to be equal to -3. And if you wanted to check it, you could, right? I mean, does -3 really give us 1/8 if we put it as an exponent for 2? You could always, work backwards and check it real quick. So let me try it. I'm going to put in a 2. I'm going to put to the power of. So I'm going to check it. I'm going to go ahead and put in my base of 2, my power, and I'm going to put in a -3 for the exponent, for the x, and hit enter. And notice it does give me this decimal, but if I hit math, enter to convert it to a fraction, it does tell me it's 1/8. So that I know for certain this is the correct answer. X really is equal to -3. Because if I replace this exponent with a -3, so 2 to the power of -3, it is going to give me a value of 1/8 for my answer. Now we have one more to do, and once again we're just going to convert this to a log. So this actually becomes log with a base of 8, and 1/2 is what it's equal to, and I'm going to say this is going to be equal to x. So I'm going to type this into the calculator, and we're going to see what we get. So I'm going to go ahead, I'm going to hit math, log base, and then I'm going to put in my 8 for my base, and I'm going to put in 1/2. For the answer, and then I'm going to hit enter. And notice it gives me these -0.3 repeating. Now if I wanted to convert that to see, well, what exactly is that, I can hit math, enter, and it tells me that it is -1/3. So -1/3. That is what x is equal to. And if you're ever in doubt, you're thinking, well, you know what, maybe my calculator didn't do something right, I didn't hit something right, well, then just test it out. Put 8 to the power of -1/3, and when you hit enter, right, it should give us 1/2. And notice that it does give me 1/2. 0.5 is the same thing as 1/2. If I wanted to hit math to convert it to a fraction, I would see that it is 1/2, if you're not good at doing that in your head. So now you know how to use logarithms to solve for x when given an exponent. Or let me rephrase that, when given a power that's missing its exponent.